So, this summer I went and visited CERN. Now, I probably should have planned the standard model video before this, but apparently I can't plan worth
Give me your attention, baby. I gotta tell you.
So, CERN. Now, CERN stands for the European Centre of National Research. Wait, no. The European Centre of Nuclear Research. It's not ECNR because it was originally in French. Now, it in French is Conseil Européen pour la Recherche Nucléaire. And I probably mutilated that pronunciation and accent, but that's okay. I'm not here to do languages, I'm here to do science. CERN's point of pride is its LHC, yay more acronyms. It stands for Large Hadron Collider. It accelerates hadrons, more specifically protons, around a ring and then collides them. The collision creates more elementary particles. I'll explain how in further detail later on. But the LHC is possibly the largest collaboration in human history. It spans 17 miles. I could rattle off numbers and figures, but that won't really mean anything. You could just look up Google. Now, while at CERN, my tour was focused on the ATLAS experiment. And there are 4 experiments: the CMS ATLAS, LHCMB, or LHCB, I believe, and ALICE. Now, ATLAS and the CMB are the 2 main experiments. The other 2 are just there. They do stuff as well, but those 2 are the ones people talk about. Unfortunately, when I visited the LHC, it was under reconstruction and upgrades and all that, and in the next few years it will be up and running, but unfortunately I didn't see any particle collisions. What I did get, however, was the shirt. It's full of equations describing the standard model, further solidifying my bad planning. What I did get was this. This is an LHC data tape which contains 1 terabyte worth of proton collisions and 8 teravolts. About 600,000 collisions. And all that 1 terabyte of data is worth half an hour. Half an hour of collisions. However, 2 problems with this. One is that it's a data tape. Tape readers are very rare and very expensive nowadays since they're almost extinct. And 2, this data isn't really special. You can find it for free on the internet. In fact, that's what the internet was invented for, the spreading of LHC data, because it produced so much that they needed to spread it all over the world. You may also be wondering why this is not in my usual place with the whiteboard, and that would be because of several reasons, but least of which I won't need it. Right now I prefer to animate things, and since the whiteboard isn't really great for animation, and since the only animation software I do have, it takes time and patience, and that's something I don't have right now, I'll be doing it in everyone's favorite software, Google Slides. This is an image of the LHC, and it's got all these complicated long names and all these arrows, but this is YouTube. You're not really meant to think here. So instead, here's a simpler version of it. So you've got the 2 Linacs, P and PB. You've got an unmarked circle, I'll explain what that is, PS, SPS, and the actual LHC. Now these are all parts of the LHC. But let's go through the journey of proton. So the proton, along with its electron, you've got your hydrogen atom. Alright, you've got your proton and electron. Now, that is fed into the P tube, where the electron is then stripped away through some magnetics. And then you've got your protons. So you've got your protons that go through the proton synchrotron booster. And so then they generate speed. Once they hit a specified amount of speed, they go on to the proton synchrotron. and then they build up speed going in a circle there, and then they go over to the super proton synchrotron. I know these scientists are amazing at naming things, and so that just spins them faster and spins them faster and faster. And after a few revolutions, the protons go through and finally enter the LHC, the Large Hadron Collider. And protons are, again, hadrons. The two groups of protons just keep revolving around, gaining speed. They don't collide, although they're close to it. And then after a few revolutions of those, the protons finally collide. And I know I'm just shifting them all over, but in reality, there are a lot more protons than just these few. And I do not have the time, nor Google Slides has the processing power able to put billions of little small red circles in. So then they collide. Then they all collide at different experiments. The CMS stands for Compact Muon Solenoid. The Atlas stands for a toroidal LHC apparatus, and the last S is capitalized. Yeah, these science guys, they're great at naming stuff. The LHCb stands for Large Hadron Collider Beauty, and ALICE stands for a Large Ion Collision Experiment. And I might have messed up somewhere there. So PB in these two lines down here actually does stand for lead ion, and the lead ions go through the same adventure that the rest of these go through, and ALICE actually detects the collision between two of them. So then you have your 4 experiment collisions. Now what happens when these protons collide is that they create an incredible amount of energy, just pure energy. And so you've got your pure energy. Now this is a representation of this energy that's created by the collisions, and so that energy then turns to particles, because energy is unstable. In its purest form, it's unstable, and it tries to consolidate itself into matter. They can't consolidate into something like a proton right off the bat. They consolidate into stuff like the quarks, leptons, and sometimes even bosons. But it's usually the quarks and leptons that are detected. That's what the explosion graphics you see when you see anything about the LHC describes. Let me just pull one up. So each of these trails, like this one, this long orange line going out here, each of them represent a particle. Through each layer of the LHC, it detects more and more particles. I'm pretty sure these orange lines out here are muons, and the rest of these might be quarks or other leptons. But then the LHC records the data about these collisions, and then they save the data in their massive computing grid, and then they just rinse and repeat. Go through the entire thing again. All the protons and the lead ions go through the PSB, and then the PS up to this SPS, and then do a few laps around here, and then collide at these 4 places. And then they collect data and repeat. And that's what happens. It starts with hydrogen gas, and then the hydrogen gets stripped away, protons get faster and faster until they finally collide, release energy, and then the data is taken and processed, put into little data tapes and spread over the internet. That's really all that happens at the LHC. The LHC isn't good for the mere act of smashing particles together. The LHC brings people together all around the world. So, contributions by CERN, the Higgs boson, internet, touchscreens, W and Z bosons, weak neutral currents, antimatter, and a lot of other stuff. But this video's getting pretty long, and I try to keep them about 10 minutes or less. So guess that's all for now. Like and subscribe if you want to, I guess. I'll be seeing you. Please actually do subscribe. I need subscribers.
A little something about yourself.